Okay, today we are working on direct variation, and by the end of the hour you'll be able to write an equation of a direct variation, and you will be able to use ratios and proportions with direct variation as well. So please write this definition down. Direct variation, the variables x and y are said to vary directly with each other. So the equation will be y equals times x. So what it's saying is your variables x and y directly relate with each other, and we'll get into further detail about what that really means here next. So my first question is this equation a direct variation? If it is, find the constant of variation. So what I know is I need to get this into the y equals k times x form. So to do that, the first thing I'm going to do is I'm going to subtract 2x minus 2x. I should draw my line to the equal sign. So I get left with negative 3y equals 1 minus 2x. I'm still goal is try to get x here by itself, so I need to divide everything by negative 3. Y equals 1 negative 1/3 minus, it's actually become a positive 2/3 x. So my question is this, sorry about that. Is this going to be in this form? Is it in the y equals kx form? Your answer should be no, because we still have this constant here. So the equation does not have the form y equals k times x, so it is not a direct variation. Now, if this was just y equals 2/3 x, and we did not have this negative 1/3, then your answer would be yes. There would be a direct variation. So understand it needs to be in the y equals k times x form. You cannot have a constant out here. Alright, your constant variation would be your 2/3 here. That is your k value, so that is your constant variation. Alright, please go ahead and do this next one. Pause the video and find and see if this equation has a direct variation. If it does, find your constant. Go ahead and pause. Alright, here's what you should have done. You should have subtracted a 2x from each side. So subtracting here, and that leaves you with negative 3y equals negative 2x. My ultimate goal is to get y by itself, so I still needed to divide by negative 3. Whatever you do one side, you need to do the other. This is going to make this a positive 2/3 x. Y equals 2/3 x. Actually ends up being what we just talked about. So this equation is a direct variation because it's in the y equals k times x form. So my constant of variation, my k value, is going to be 2/3. So understand your constant variation is your k value. Next part of today's lesson is being able to take a point. So the point we're working with here is negative 3, 2. Take this point and write an equation with it. So when we do that, you're going to take it and make it into your y equals k times x form. So once again, we're taking this point and making it into y equals k times x form. What you're going to do is you're going to plug your values in here. So my y is a 2 value, so 2 equals k times my x is negative 3. So as you can see, same concept. They substituted your 2 and 3, negative 3 value in, divided everything by negative 3 here to get k by itself. So my constant was negative 2/3. Write it into the equation. Y equals negative 2/3 x. So this is your k. Just replug it back in, and this is how you start with a point and finish writing it into a direct variation. The weight varies directly with the mass, so we can use our direct variation because your two variables here, your weight, varies directly with your mass. So x is going to be 6, y is going to be 59. Where do they get that? 6 is given the mass of the bowling ball, and then 59 is going to be what the scale reads. So we know these values. We know x, we just said, was 6. It was the mass of the object. Y was 59, and it was the weight of the object. So I can take these and put these, since I know it varies directly with, plug it into my y equals k times x direct variation equation, which is right here. And this is what we're going to get. Plug in your values. We just said y was 59 equals k, and x was 6. So when you plug in, we need to divide. We're trying to find that constant here. We're trying to find k. 59 divided by 6 equals k. Take your k value, plug it straight back into y equals k times x form. So my equation, y equals 59 over 6 times x, relates the weight of an object to its mass. So there is your direct variation equation. I'm not going to have you do another one of these like I didn't with the points either, so make sure if you have questions when you start to do your practice problems, you go back through and rewatch this video, or look at your notes. So now I'm going to give you a table, and I'm going to ask if this table, whether x and y, this ratio here, varies directly with each other. So to do this, I'm going to have y equals k times x form. This is what I'm given. I'm looking to see if x varies directly with y. So to do that, I need to find my constant. So I'm going to divide by x. So y over x equals k. And once again, your k is your constant. So here, take a look. Plug in my y. So now take this is what's given, and I need to see if my constant, my k, is the same throughout. So here's back to my same table, but now just showing, I just showed where you got y over x at, and why that's in this third column. So -2, 1, my y value is 1 over -2, -0.5 is my k. Here, my y value is -1, that goes on top. K is 2. And -0.5 is my k again. Same here, -2 divided by my x, which is 4, equals, so yes, the constant of variation, my k, is -0.5, so the equation is this, and since all my k values here were the same, it is a direct variation. If my k values were not the same, it would not be a direct variation. Go ahead and do this one, pause the video, and see if this table is a direct variation. So if the y's and x's vary directly with each other. Here's the table you should have gotten. So we got -2, 2, and -2. And since they are not the same k, we have a -2 and a 2, it is not a direct variation. Last part here. So here is a kind of a force problem. So a windlass requires 0.75 pounds of force to lift an object. The weight, and it weighs 48 pounds. How much force would you need to lift 210 pounds? So kind of retaking what's important here. The force, 0.75 pound, lifts 48 pounds. So how much force do I need if I'm going to lift 210 pounds? Well, we can put this into proportion. So here I have force 1 over my weight 1 equals force 2 over my weight 2. Go ahead and fill in with what you know. Okay, you're going to have one variable. One of these values is going to be a variable because we do not know. That is what we are looking for. So go ahead, pause the video now, and fill in your proportions with numbers. Here's what your numbers should look like. So filling in 0.75, 48, 210, and this is what you are looking for. Go ahead now, pause the video, and solve for n. Now that you have solved for N, you should have gotten 3.3, about 3.3 pounds of force. So take with this answer and bring it back into your question. You'll need about 3.3 pounds of force to lift 210 pounds. Go ahead and work on your practice problems at this time.